All right, so today is February what? 10th. So you're going to rewrite, simplify, and solve radical expressions and equations. Number 1 asks you to use the properties of exponents to prove that 64 raised to the 4/3 is equal to 2 raised to the 8/2. So please split, write down the equal sign so you have a left side and you have a right side. And I'm going to break this apart in two parts. So it's 64 raised to the 1/3 power, all raised to the 4th power. As a reminder, we take care of the bottom number in the rational exponent first. This means what number times itself 3 times equals 64, and the answer is 4. And then now we're going to apply and evaluate 4 to the 4th. Grab a calculator, please do 4 to the 4th. You need to have a calculator today. 256? So let me go over this one, and then I'm going to go over a misconception. You have a problem just like this on your test and a problem just like this in your test. I need you to listen to me. Can everybody take out that packet that I asked you to have that's a stapled packet as well? Do you see how number 1 and number 3 are just like number 1 and number 2 from what I'm going over? So if you happen to work a little faster than I'm going and you catch on to the concept, feel free to do that part of the homework. Does that make sense? All right, here we go. So I'm going to do the exact same thing on the right-hand side using properties of exponents. First, I'm rewriting it as 4 to the 1/2 raised to the 8th power. This means the square root of 4, or what number times itself 2 times equals 4? The answer is 2. Can you please take 2 to the 8th for me? 256. Okay, I just proved that 64 to the 4/3 is equivalent to 4 to the 8/2. Somebody in a previous class asked a great question. They said, why can't I just reduce 8 divided by 2 to 4 and then plug in 4 to the 4th on the calculator? And the reason why is because you have to use properties of exponents, which shows you understand how rational exponents work. That's the reason why. Okay, so that is like number 1 from your homework. We're going to go on right now to number 2. There are 3 steps to number 2. 3 steps to number 2. The first one is figure out which step is a mistake made. Then explain what mistake is made in words, and then actually correctly solve it. So start with 16 on the inside. What number is hidden right here? A 2. So it is 5/2. When you break that apart, it's 16 to the 1/2 power, taking care of the bottom number, the denominator in the rational exponent, and then raising it to the 5th. This means the square root of 16, or what number times itself twice gives you 16? The answer is, grab a calculator, take 4 to the 5th power for me, please. What is it, honey? Okay, there's 3 parts to this. One part is figure out the mistake, then write in words what they did wrong, and then solve. I've already done the solving, so I'm done with that. I'm going to compare my work with their steps. Okay, so here we go. Step 2 is good. Step 3 is where the mistake is made. Now you need to articulate what mistake was made. So instead of rewriting this as a 1/2, they wrote it as a square. That was their mistake. Please put that in words. I know it's been nearly a year since you've had the AZ Merit exam. Your AZ Merit exam does a lot of problems like this. Identify what step there's a mistake in, what should have been there, and what is the correct answer. Okay, we're going to move on to number 3 of the 10 problems today, and I'm trying to move at a pace where you understand and also allow you the opportunity to start on your homework. Can you do me a favor real quick, just so I know? Remember, you have a quiz on Monday, and I want to go over a few problems before you take your quiz. I want to go over the problems you feel are most difficult. On a 1 to 5 scale, 5 being I completely understand, where are you for problem 1 and 2? I'm only going to go over the problems where you feel are most difficult on Monday. Okay, so the majority of us feel okay with this. Remember, if you need to, go back and watch the film. Let's go on to number 3. This was a problem that most people struggle with. Do me a favor, it's going to help you today. Take out that paper that said class notes. It looks like this. We're going to refer to that and that will help us. Take this out. I'll give you a minute to do that. Okay, please right now look at number 5. So this is a blank paper that was, again, from the class notes from the previous lesson. Number 5, the rule is when you have the same exponents and you're multiplying or dividing, we get to do the operation. So in this case, we took 16 to the 1/4 power. But this is in rational form. That's why this looks so different, okay? So let's rewrite this. I'm going to give you time to do this. Please do this on your own, on your paper. Okay, you ready? Let's go with the easy part. 2 times 3 is 6. Done. That's easy. Okay, here we go. Same exponent. 16 times 2 is 32. And I'm going to write it to the 1/5 power. I'm going to come back to that in a little bit. Okay, don't tell me there's 2 a's. Yes, there's 2 a's, but look at their exponents. How many exponents do we have when we add up the a's? A to the and b to the 30. Thank you. Here we go. Evaluate. 32 to the 1/5 power is what? 2. So this is 2. And 6 times 2 is 12. Now this is easier than it looks. This is where we talk about, if you can look over in the back side and find problem like 15, problem 15, problem 16. This is where we talk about how many groups of 5. So how many groups of 5 can you take out of 20? How many groups of 5 can you take out of 30? Problem done. That's a tough problem for most people. Okay? Do me a favor right now. I'd like you to check with your partner. I'm not going to have somebody explain it unless it's needed. Check with your partner just to see, do they need any help? And don't be embarrassed if you do. This is one of the toughest problems for today. Go. If Ulysses, if it doesn't come back, I'm just going to have you scoot over there if he doesn't come back, okay? Okay. This problem. Yes? Okay, help me out, because I want to only go over the problems that you feel like you need to review before the test, and I'm only going to have a chance to do a few, or a quiz, excuse me, on Monday. So on a scale from 1 to 5, how well do you understand this problem? 1 to 5 right now. Okay, mostly 4s and 5s. Impressive. Go down to number 4. Before I do number 4, I want you to look at the class notes really quick and find number 15 from the class notes. So a lot of students say, I understand once you start doing a problem, but I don't initially know how to get started on my own. Circle the nth root. N means what is the number, okay, like cube root, fourth root, square root, okay, so the nth number. So I want to think of numbers that go with multiples, that are like 1 to the 4th power, 1, and 2 to the 4th power is 16, or 3 to the 4th power is 81. 4 times what number gives me one of these numbers? 4 times 4. So extend the radical out, and we're going to multiply the top and bottom by 4 to the 4th. So now I have on top 12 to the 1/4, and on the bottom 16 to the 1/4. And why do we have to do that? Because we cannot have a radical in the denominator. What is the 4th root of 16? And the 4th root of 12 exists, but it is not a pretty integer. This problem is done. Check with your partner. 1 to 5 real quick. You guys are the ones telling me what I'm going to do tomorrow for all my classes. 1 to 5, where do we stand? Majority of us are 4s to 5s. Okay, here we go. This is one of the longer problems, and we're going to use a calculator to do it. Okay, I'd like you to look back at the class notes at number 1 and number 4. So I'm going to call on students' names. Listen if I call on your name. Ready? Fernanda, you're first. Look at number 1. What is the rule for number 1? Do you want a little hint, Fernanda? That could be used, but there's another rule. Okay, so Fernanda just did like a real simple version, but this is what she's saying. The version is, this is the rule. When you have the same base and you're multiplying, everyone, add the exponents. When you have the same base and you're dividing, you subtract. Okay, we're going to use that concept, and you're going to use a calculator to make life easy. Do you see how the bases are all the same here? I want to put them in the same form. That means I want to put them in rational form. So I have x to the 1/20th times x to the 3/5 times x to the -7/10. And a few students in previous classes said, Ms. Bradley, you can't do it because you have negative exponent. Your final answer can't contain a negative exponent, but as you simplify, you can have it. Grab a calculator right now. Put in parentheses 1/20th plus parentheses 3/5 plus parentheses -7/10. Okay, I got to remember from previous classes, did I get -1/20? Okay, thank you. So there's the top, and now I'm going to rewrite this on the bottom as 1/4. Okay, now this goes back to like problem number 4 from our last lesson. When you have, sorry, to make sure you guys can see it, when you have the same base and you're dividing, you subtract. Grab a calculator. Please write. Type into that calculator -1/20. Make sure it's in parentheses. Subtract 1/4. A little bit louder for me, Jazz. Okay. If I left my final answer like this, would that be acceptable? No. Sons, why not? Good. So where do I put it, sons? Okay, now I can completely understand that somebody understands the concepts. They get to this point, they think this is the answer. But here's the tough part. This is not the final answer. I'm going to put you on the spot here. Ready, Isaiah? What number goes inside right here and what number goes outside, Isaiah? How do you know that? Is it because it's a larger number? Nope, good. Why is it? Yeah, the denominator of the rational exponent always goes on the outside. Okay, so now I want you to look at this, turn back, and find number 15 from class notes. Look at number 15 from our last lesson. How many y's did we have to attach to the bottom and top? 2, right, to get the multiple of 3. Well, now I have a multiple of 10, so how many do I need to attach? 7. Okay, let's do 7 to the top and 7 to the bottom. How many groups of 10 can you take out of 10? 1. We no longer have broken math rule. Is that the phone that's on off? Servando, can you get it for me? And our top is just fine. Can't be simplified. Problem done. Between you and your partner, that's the longest problem we're going to have to do today. Choose whoever understands it best. Going to give you 30 seconds. Please look through. What'd you say, honey? I'll be right there. TJ. just went to the nurse. All of his stuff. Okay. Who was it? Okay. Yes, Pedro. Say it again for me, Pedro.
Why did you subtract 1/4 to negative 0?
Why did I do this initial subtraction here? Well, there's a couple different options you could do, Pedro. One is you could do the...
He's dividing.
Yeah. You understand? Okay, because there is more than one option to move through this. You tired, Diego? Do you understand the concept?
I got lost in year 10, but then I think I got back on track.
Okay. Do you understand, Jasmine? Can you get the phone for me again? If it's about the gentleman you just said, all of his stuff is in back. Okay, Servando? Okay, we're going to move on to this problem. Number 6, can everybody please look back at class notes and find 10, 11, and 12? Did you? Okay. 10 and 11 and 12. Here we go. Ready? So here's the deal. I'm going to go through this fairly fast and you just pay attention because there's not going to be a lot of steps. It's a conceptual thing. Please take 243 and raise it to the 1/4 power and tell me if it's a nice, pretty integer answer. Somebody's at the door. Who is it? Okay. So is it a nice, pretty answer? Okay. Here's your hint. For this particular problem, we're going to find the smallest number, which happens to be right here. Happens to be this 3. And that's going to be our hint on how we can take and further simplify this. I can simplify it real quick. Okay. That's okay. You guys want to do this? Refer to right now to 10, 11, and 12 real quick for me. I'll be back in like in 1 minute. Totally curious. Before I get the answer put up, does anybody have an answer? What do you have?
17, 4 to the third.
No. You got the second part right. Anybody else have an answer? Yes, what do you have? No.
Yeah, negative 2.
No.
10, 4 to the
Yes. 10, what?
10, and then that little 4, and then the square root of 2. It's like
I think he's right. I think Servando's right. Don't get arrogant, Servanto. Don't get arrogant. Okay.
I don't know how to say the 4 thing.
Okay, 4th root.
4th root.
Okay, so here we go. This is going to be your hint. Because this does not evaluate to give you a nice integer answer, your smaller number should be your hint. So take 243, I'm going to go through the whole problem, and divide it right now in a calculator. Use a calculator, divide it by 3 quick for me, please. 81. So I'm going to write 81 to the 1/4 and 3 to the 1/4 because 81 times 3 is 243. Leave this where it is because 3 to the 1/4 is not a nice integer answer. Take 43 and divide it by that small number. 43 divided by 3 is what? It's 16. So I have 16 to the 1/4 times 3 to the 1/4 because 16 times 3 is 48. So I've just rewritten it in equivalent form. What is the 4th root of 81? 3 times 5 is 15. Minus 9. And what is the 4th root of 16? And 2 times 3 is? I'm sorry, 2 times 2 is 4. So now I have 15 star minus 9 star plus 4 star. Do you have to do the stars? Absolutely not. That's just the way I'm explaining it, okay? 15 minus 9 is 6, and 6 plus 4 is 10. So 10 star, and we really don't have a star. We have the 4th root of 3. Isn't it 2 star? Well, show me where my math is wrong, and you may be right. Show me where I'm wrong. 2 times 16 to the 1/4.
16 to the 1/4.
2, and 2 times 2 is 4.
Okay.
Are you sure? Does anybody else see a mistake? If you do, please let me know. Okay? So my explanation right now, 1 through 5, how well are you understanding the explanation? 1 through 5 right now, so I can see. Hands up high. Okay, it looks like this is a little bit harder problem for most people. This will be one of the ones I do similar to it before you take your quiz, okay? We're going to move on down to number 7. It is my opinion right now, if you have strong algebra 1-2 skills, don't take time. No, what's going on? If you have strong algebra 1-2 skills, go ahead and do number 7 without my help. Just start, okay? I'm going to explain it in case you don't know where to start. Your goal is to get this radical, which is a square root, all by itself. So first look, we have it outside. We have a negative 1/4 and we have this positive 2/3. So we're going to start by getting rid of stuff that's being added or subtracted outside of the radical. So I subtract 231 to both sides. Okay, now I need to get rid of the negative 1/4. It's being attached by multiplying to this radical. So normally, to get rid of something that's being multiplied, you divide it. And you still could divide by negative 1/4, but because it's a fraction, we often multiply by the reciprocal. Multiplying by the reciprocal does not change the sign. The negatives, 1s, and 4s cancel, and now I have the square root of 5m plus 56 equals negative 16. This is a square root. You learned that to remove a square root or cancel it out, you square both sides. So I square both the left and right, and the square root and the square cancels. When you plug this into your calculator, you must put it in parentheses. If you don't put the negative 16 in parentheses, you're going to get the wrong answer. So negative 16 squared is, now subtract 56 from both sides, and we have 5m equals 200. Divide by 5, and m equals 40. All right, so how many agree final answer is 40? Hands up high. Who can tell me why it's not 40?
I'll teach you a check for
Check for what?
extreme.
Extraneous solutions. So grab a calculator. We're going to do it together. You ready? We want to use the calculator as a tool to make our life easy. Take 5 times 40, press enter, and add 56. Tell me your answer. 256. Do you guys agree with sons? Take the square root of 256. Take it times a negative 0.25. Add 231. Do you get an answer of 235? Yes or no?
No.
If your answer is no, that means this is an extraneous solution. We did all of the math correctly, but our answer does not work out. Daniel, do you disagree with me? Are you confused? Do you want me to run through it with you real quick? Okay, here we go. Do you agree, Daniel? Look up here. Do you agree 5 times 40 is 200 and 200 plus 56 is 256? Take the square root for me real quick, Daniel, of 256. Get an answer. What do you have? Take it times negative 0.25. Are you sure? Okay, here we go. Now this one, I need to show you some problems that are similar to it, that look similar but that are not exactly the same. So for this problem, we have a cube root. So I have a radical with nothing outside of the radical on the left and a radical on the right with nothing outside of it. And we have the exact same nth root, which happens to be a cube root. When that occurs, life is really easy. Cancel out the cube roots on both sides and write down what you have. Please solve for x. I'll give you 10 seconds. Nick, do you have an answer? X equals 9. Who hands up agrees x equals 9? I think you're really close, Nick. Let's try again. I'm going to start by subtracting 2. When I subtract 2, I get 3x plus 32 equals 5. Now subtract 32. I have negative equals 3x. That means you're really close, Nick, but the answer is actually... Okay, so now there's misconception with previous classes with this too. So even though this is an easy problem, answer this for me. Can you evaluate this answer and get a real answer? What's this answer? Negative 2. Yeah, it works. What is this answer if I want a real number? Can't do it, right? What about this one? What is it? Negative 2. What about this one? So when the nth root is even, you can't have a negative inside. But when it's odd, you can. Does everybody understand that? So we're going to go back and we're going to do quick math here. You're going to grab a calculator. Take negative 9 times 2, add 5 to it, and tell me what you have. Okay? Is that possible? Yeah, because it's an odd nth root, so we can have a negative inside. We're going to do the same on the right-hand side. Take 5 times negative 9, get an answer, and add 32. What do you have for an answer? Negative 13. It works. Left side equals the right. We're good to go. Flip to the back side, please. We're getting close to being done. Now, what's been really surprising is every single person I've asked today about number 10 has got the answer right when we start out. But in years past, I consistently would have students get the wrong answer. So I'm going to call on somebody. Servando's already raised his hand. Let's see what he tells me. Okay, ready, Servando? We have a left side and a right side. Do you agree? So back in 8th and 9th grade, when you wanted to solve for a variable and you wanted to eliminate a square root, you'd square both sides. So everybody at this time, please square both the left and the right. On the left-hand side, the reason you're squaring the square root is so it cancels. Servando, can you please square what's in parentheses and tell me the answer? Servando, are you sure about that? Okay, Leslie, do you agree or disagree with Servando's answer?
Agree.
How did you get that, Leslie?
Because we multiply 2x times 2.
Multiply 2. So if I take 2x times 2 like you told me, Leslie, then I'd have just 4x.
Oh, 2x.
Okay, so you're saying take this and write it twice and now multiply. So 2 times 2 is 4 and x times x is x squared. Is that correct, Leslie? You are right. Servando got it right. Okay, just checking if you're... Okay, I'm going to move everything to the same size as the square, and I'm going to start picking up speed here. So when this moves over, it is going to be a positive. When this moves over, it's going to be negative. And now I'm going to do bottoms up. Yes?
So you square everything?
You square both sides. Yep, everything.
Everything inside is like that 2 and the x.
Mm-hmm. Yep. Okay, so I'm going to do bottoms up. What multiplies to give you negative 24 and adds or subtracts to give you a positive 3? Positive 8 and... Servando, you're on a roll. Here we go. Ready, Servando? Solve for me. Do you agree real quick the answer is x equals negative 8 and x equals positive 3? Yes. Sons, do you agree? Why sons? Bottoms up with a 4. Remember, leading coefficient is different than 1. You got to divide by 4. Gotcha, Servando. All right, so now we have x plus 2 and x minus 3/4. So this is in factoring form. It gives us the exact answers. X equals negative 2 and x equals 3/4. What do we have to check for, Diego?
Oh, exchange division.
Okay, so what is the decimal form that is equivalent to 3/4? 0.75. Grab your calculator. Are you ready? Take 6, subtract 5 times 0.75. Take 6, subtract 5 times 0.75. Then take the square root of that value. Can somebody share with me what you have?
1.5.
1.5. Does anybody else have Diego's answer to confirm? We're good? Thank you. Take 2 times 0.75. I'm checking, does the left side equal the right side? It does? Okay, that means this answer is correct. Now let's check negative. Now I want you to use common sense here. Sergio, you ready? Answer this for me. All answers to square roots are either going to be, so real numbers, are either going to be 0 or what type of number? Positive. Did everybody hear that?
Yes.
All square roots are either going to be 0 or positive. Thank you, Sergio. Look up here. If I plug in a negative 2, forget about the left side right now. If I plug in a negative 2, 2 times negative 2 is? So can a negative 4 be equal to the answer of a square root? Cross out extraneous solution. Go up to number 9. We want to find integer solutions like negative 3, negative 2, negative 1, 0, so on. Okay? So we want to have pretty integer solutions. All right, so grab a calculator. Take the square root of 80. Tell me if it's a nice, pretty integer solution. No. So if you have this ugly number and then you add 40 to it, does it magically turn into an integer?
No.
Cross it out. That is not an integer solution. I'm going to go on to Roman numeral number 2. I have radical 4x equals 2. Just like we did for the previous problem, how do we eliminate a radical? Square both sides. 4x equals 4. What's my next step? Divide by 4, we get an answer of 1. Is 1 an integer?
Yes.
Circle. Let's do some mental math. The square root of 9 is 3. 2 times 3 is 6. So I have x subtract 6 equals 16. I add 6 to both sides, and I get x equals 22. Pretty answer? Done. When I say pretty answer, I'm referring to a nice integer number. Is the cube root of 25 a nice answer? If you don't know it, you plug in 25 raised to the 1/3 power, and it's going to show this ugly decimal. It's irrational. So if you have an ugly decimal, and then you subtract 6 from it, is it still going to be ugly? Yeah. Cross it out. This is the most missed problem that I've had today. What is the square root of 100? So students saw this, and they saw pretty answers, and they said, yes, this is an integer answer. But to solve this, you still need to. So take 10 divided by 6. They're both integers, but when you divide them, you get a nice integer answer. It's a decimal. Cross it out. Square root of 16 is?
4.
So what does 4 over 8 reduce down to? Again, how do we eliminate a square root? we square both sides. 1 squared is 1 and 2 squared is 4. Although 1 and 4 are both integers, 1/4 is a decimal or a fraction. It's not an integer, so we get to cross out Roman numeral 6. Okay, please look at the